In this video, let's go ahead and try an application word problem dealing with the coordinate plane together. Now, to get the most out of this video, I encourage you to grab some paper, something to write with, and let's do some math together. Alright, so it looks like Mr. Mount is going to be installing a fence around his giant rectangular trampoline so people can stay safe on it. He's planning out the installation of the fence on the trampoline by plotting a sketch of it on the coordinate plane that you can see over here. So we have four corners here, corner 1, 2, 3, and 4. We're going to label those J, U, M, P. All right, so let's go ahead and get started with plotting some of these points first. All right, so for plotting J, let's start at the origin. The -3 means move 3 units to the left, and then the -8 means 8 units down. So we should be down here in quadrant 8. This looks pretty good right here. Okay. What about U? Let's go with U and just kind of plot it here. So for U, let's start at the origin. We're going to move 3 units to the left, so 1, 2, and 3. Then we're going to move 1.5 units down, so 1 and then 1/2. So just like this. That's halfway between those two lines. I think I'm going to move this J on the bottom here, just because I think it's going to be in the way in a little bit. For M, let's go ahead and see how we're going to plot M. Start at the origin here. We're going to move 5 units to the right for that +5, and then we're going to move 1.5 units down. So here's 1, and then here's 1/2. Should be between -1 and -2. And then finally for P, let's go ahead and start at the origin here, and then P is going to move 5 units to the right. That's going to be right over here. And then we're going to move 8 units down over in quadrant 4. So this looks just about right at 5, -8. Now same thing, let's go ahead and move the letter P down to the bottom here. In terms of writing the letter P, I'm going to move that to the bottom again, just so it's not in the way here. Now for our sketch, let's draw segment JU, segment UM, segment MP, and segment JP. This would be a sketch of where the fence would be for the trampoline, and the trampoline would be in the middle. All right, that was all we had to do for part A. We just made an accurate sketch, and we just kind of labeled everything. So for part B, let's go ahead and find the length of segment JU by using an absolute value expression. So JU, that's going to be these 2 points right over here. So you can just look at these 2 set of coordinates. They have these matching X coordinates, so don't use those. That just lets us know that they are vertical points to each other. If we look at these 2 Y coordinates, they are in the same quadrant because they're both negative. So let's go ahead and subtract their absolute value. So we can say segment JU would be equal to the absolute value of the number that is further from 0, the greater absolute value, minus the one that has a lesser absolute value, the absolute value of -1.5. So if we go ahead and evaluate this, this is really just going to be 8 minus 1.5, and 8 minus 1.5 is going to be 6.5. So looks like segment JU is going to be 6.5 units long. All right, let's see. For part C here, we're going to go ahead and find the length of UM, segment UM. Let's go up again and take a look at segment U and M. So that's going to be these 2 segments right over here. Notice how they have matching Y coordinates here, which makes sense because these 2 points are horizontal to each other, or left and right to each other. And then look at these X coordinates. Well, one's negative, one's positive, so they're in different quadrants. And when that happens, you add the absolute values of these 2 X coordinates. We have -3 and 5. So let's go ahead and write that out. What do we say? We had -3 and 5. So we have segment UM. It's going to be the absolute value of -3 plus the absolute value of 5. That's just going to be 3 plus 5, right? 3 plus 5, and that's going to be equal to 8. So segment UM is going to be 8 units long. All right, next for part D, we're going to find the length of MP. Now keep in mind here that segment MP, that's this segment right over here, that's going to be the same segment as UJ. So we're going to use the absolute value expressions as well, but you already should know right now that the UJ or JU is going to be the same thing as here, 6.5 units. So we know what the answer should be, so we can always just double check that along the way. So let's see, segment MP, let's go ahead and look at these 2 letters of M and P. They have matching X coordinates, which makes sense. They're vertical to each other. These 2 Y coordinates are in the same quadrant, so we should subtract their absolute values. So we have -1.5 and -8. So let's go ahead and say that we have the -8 first, and then minus the -1.5, the absolute value of it. Again, the one with the greater absolute value is going to go first. Then if we subtract their absolute values, it's 8 minus this 1.5. 8 minus 1.5 is 6.5. So this does, I think, make sense because we had 6.5 units for the segment on the other side of the rectangle as well. So 6.5 matches what we got in part B, which is also 6.5 units. All right, let's take a look at E here. For E, we have to find the length of PJ. Now keep in mind that PJ or JP is going to be congruent or the same length as UM or MU. And so we should get an answer of 8 here. So let's look at the coordinates for P and J. So here's P and J. They have matching Y coordinates. And then so if we look at their X coordinates, they're in different quadrants. We should add their absolute values. Okay. So for segment PJ, let's go ahead and take the absolute value. Let me just see those numbers one more time. I think it's going to be negative, let's see, negative 3 and 5, right? Yeah, negative 3 and 5. So it doesn't matter which one goes first because we're adding. So it's negative 3 in the absolute value plus absolute value of 5. That's going to be 3 plus 5, and that's going to be 8. So looks like segment PJ is going to be 8 units long. All right, so now that we know the measurements of each of the segments in units, that's going to be the sketch of the fence of the trampoline on the coordinate plane. What about in real life? Well, we're told that 1 unit on the coordinate plane is actually 2.5 feet in real life. So each one of those lengths of a box on the coordinate plane or square is actually 2.5 feet in real life. So let's go ahead and figure out the measurements of JU measured in feet instead of units. So let's go ahead and do that. Segment JU, let's see how long that was in units. For JU, well, that was 6.5 units, right? So let's go ahead and deal with that. So we have 6.5 units, but each one of those units is actually going to be 2.5 feet in real life. So if we multiply this by 2.5, we'll figure out what segment JU is measured in feet instead. Okay, so we have 6.5 or 65 multiplied by 25. We can just ignore the decimals. Our answer is going to be 100 times too big, but we can always just put the decimal back in, make it 100 times smaller afterwards. So we got 25 here. We got 30 plus 2. That's going to be 32. We got a placeholder. We got 10, carry the 1. We got 12 plus 1 is going to be 13. If we go ahead and add here, we're looking at 5, 2, 6, 1. And I think we need to put 2 decimal places in because we made it 100 times too big there. So it looks like this is going to be 16.25, and that is going to be measured in feet. So that's how long JU is measured in actual feet. Okay. All right, moving on. For letter G, it says same conversion. 1 unit is 2.5 feet in real life, but this time we're going to do UM. So let's see how long UM was. Looks like UM was 8 units, so let's go ahead and use that information. UM here is going to be 8 units, but we're going to convert that to feet. So each one of those 8 units is actually 2.5 feet. So let's go ahead and multiply this out. So let's go ahead and ignore the decimals. Let's call this 25 for a moment and call this 8. 25 times 8, that's going to be, let's see, that's 40. Carry the 4, that's going to be 16 plus 4 is going to be 20. So that's 200, but we ignored 1 decimal place, so this is going to be 20.0 or just 20 feet. Okay, so segment UM in feet is going to be 20 feet long. The next one we have here is going to be MP. Now MP, keep in mind, is going to be the same thing as JU. So if we take a look at what we had for JU just a moment ago, we got 16.25 feet, right? And so the work here is going to be basically the same. So totally up to you how you want to kind of think about this, but it's going to be 6.5 times 2.5. You don't have to do the calculation, but you can still write the work down, right? So MP is going to be 6.5 units. Multiply that by 2.5, and we can say that's just equal to 16.25 feet here. So we can go ahead and write that segment MP is going to be 16.25. Again, you can write the work down again, just don't worry about the calculation because we hopefully did it right earlier, okay? But MP, again, is the same thing as JU. So if you look at the picture again, MP and UJ or JU are going to be the same here, okay? So we have those two matching, which is great. If we take a look at I, we have this length of PJ, and we want to do it in feet now, right? So same idea here. We don't have to redo any work. Let's just, or any calculations rather, but we can just write the work. PJ was the same thing as UM, so it's 8 units. And if you want to convert that to feet, you would just multiply that by 2.5, right? So 8 times 2.5, that's going to be, we said earlier, was 20. And so it's going to be 20 feet here. So don't worry about those calculations, okay? All right, now that we have everything in feet, let's go ahead and figure out some perimeter and some area, it says we're going to do this in units and in feet here. So let's go ahead and try it in units first. So the perimeter is going to be 2 times, let's see, 2 times, we can do JU, which we know is going to be 6.5 units. So 2 times 6.5 plus 2 times the other dimension, which is going to be 2 times 8. So it's a little confusing with these dots, so I'm going to use parentheses instead to show the multiplication. Let's see, 2 times 6.5 is going to be 13. 2 times 8 is going to be 16. Feel free to write out the standard algorithm if you need to. And adding these two together, we're going to get 29. And this is 29 units, so that first one we just did here is just going to be measured in units. Now what about measured in feet? Well, this time it's going to be a little different. Let's see, the 6.5 we said was the same thing as 16.25. That's measured in feet. And then for the other one, we have 2 times what? I think it was 20, right? 2 times 20. So if you double 16.25, if you double 16, that's 32. If you double 0.25, it's 0.50. So we're looking at 32.50 or 32.5. Plus 2 times 20 is going to be 40. If you add these two together, we're going to get 72.5. I think that's going to be measured in feet, 72.5 here. And don't forget, this one was in feet, all right? So this was what our perimeter is in units, and this is what our perimeter is in feet. Okay, cool. Now let's go on and try the area now. We're going to find the area of the trampoline in terms of its sketch in square units. That's on the coordinate plane, and then convert that into square feet in actual real life here. So let's see, for area, it's going to be length times width. In terms of units, I think we had, what, 6.5 units, but we're going to multiply that by the other dimension, which is going to be 8 units, right? So we're going to do 6.5 times 8. That's the same thing as what, 65 times 8, and then put the decimal back in after. So that's going to be 40, and then 48 plus 4 is going to be 52. So I think this is going to be 52.0. So the area here is going to be 52. This is going to be units squared, or square units. Now, what about the area in square feet? Well, in this case, we have 16.25 feet by the other dimension of 20 feet, right? So we really just have to multiply the length and the width together here. Let's go ahead and multiply 16.25 by 20 here. Now the first 0 is just going to have 4 zeros. That makes it nice and easy. Put a placeholder here. Then 2 times 5 is going to be 10. Carry the 1. 2 times 2 is 4 plus 1 is going to be 5. 2 times 6 is going to be 12. Carry the 1. 2 times 1 is 2 plus 1 is going to be 3. All right, so it looks like if we add our partial products together, we're going to have this right over here. And we ignored 2 decimal places earlier, so we got to put 2 decimal places back in. So we're looking at an area of 325, and it's going to be square feet. Okay, so for our first area, just measured in square units, is going to be 52. And then for our area in square feet in real life, it's going to be 325 square feet. All right, so that just about wraps up this video. Hopefully you found the video helpful in terms of practicing and applying your understanding of the coordinate plane, as well as dealing with some rational numbers. In this case, we did a lot of work with some decimals. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.